These are your instructions. In general, you just need to follow the PowerPoint. Please make sure the sound is turned up on your device so you can hear the narration. Your instructions are in yellow boxes on each slide. If a slide asks for homework, don't forget to send it in via Show My Homework. And if a slide asks for Educate to be completed, don't forget to do it by the date given. By the end of this lesson, you should be able to draw distance time graphs and extract information from the lines and slopes. And you should also be able to determine the speed from a distance time graph. This is our starter activity. Can you recall what the difference between speed and velocity is? And can you remember the formula for calculating speed? Pause the recording here while you write your answers in your book. Hopefully you remembered that speed is a scalar quantity. It has size but no direction. But velocity is a vector quantity. It has both a size and a direction. And the formula you need to remember is speed equals the distance traveled divided by the time taken. If an object travels in a straight line, we can show its motion on a distance time graph. On the graph, on the x-axis across the bottom, we always show time, and on the vertical y-axis, we show the distance. Let's have a look at a worked example. A person walks for 100 meters in a straight line. This part of the journey took 100 seconds. Then they stopped and rested for 40 seconds. Then they walked faster and covered another 70 meters in 50 seconds. How can we represent this journey on a distance time graph? So to start with, we can draw ourselves some axes. And you can see that I've drawn some here. Across the bottom here on the horizontal axis, I've got time in seconds. And up the vertical axis, I've got distance measured in meters. Now the first point that we can put on is here, because we know when the person's journey starts, they haven't covered any distance. So we can plot a point at 0 distance and 0 seconds in time. For the first bit of the journey, we have this information. The person travels 100 meters in 100 seconds. So we can plot a point here. For the next part of the journey, the person is stationary. Stationary means they're not moving. So for 40 seconds, between 100 and 140 seconds, the time increases this way, but the distance doesn't increase. The distance stays at 100 meters. And then for the last part of the journey, we know that in the time 50 seconds, so from 140 to 190 seconds, the person covered an extra distance of 70 meters. So that takes them from 100 to 170 meters. So we can plot a point there. So now we've plotted points for 3 parts of the journey. All we have to do is join them up, and that is our distance time graph complete. You can use a distance time graph to work out the speed of an object. You can do this by reading off the graph the distance and the time for the part of the journey that you're interested in, and then you can use your formula of speed equals distance divided by time. If we go back to our worked example, which looked like this, we can now use this distance time graph to work out the speed of the person on the various parts of the journey. So for the first part of the journey, the person travels 100 meters, which you can read off this scale, in 100 seconds, which you can read off this scale, and then you use the formula speed equals distance divided by time. Put your figures in. That makes the speed 1 meter per second. For the second part of the journey, the time is increasing, but the distance traveled isn't. However, speed equals distance divided by time. The distance is 0, the time is 40 seconds. That gives you an answer of 0. The person is not moving. For the final part, we can read off the distance covered is 70 meters, of this scale. So from here to here is 70 meters, and we know the time from 140 to 190 is 50 seconds. Speed equals distance divided by time. If you put in your figures, it gives you an answer of 1.4 meters per second. Now you should note that this part of the journey is steeper than this part of the journey. How steep the slope is, the gradient, tells you how fast the person is moving or the object is moving. So here they're moving faster than here because the line here is steeper than it is here, and that is borne out by our calculations because here he's traveling at 1.4 meters per second and here they're only traveling at 1 meter per second. So the gradient or slope shows you how fast they're traveling. Moving on from that, if you have a curved line and the gradient shows you the speed the person is traveling at, if you look at this line, the slope of the line is increasing. That means the person's speed is increasing. And we have a name for that. We call that acceleration. The opposite to that is shown here. As the slope of the line decreases, that means the person is slowing down. And we call that deceleration.
Now, the most complicated thing you can be asked to do with a distance time graph is to work out the speed of an object which is either accelerating or decelerating. So let's have a look at that situation here. Here we have the distance time graph of an object. Now, straight away, because it has a slope, you know that it is moving. It has a speed. And because the slope is increasing in steepness, the gradient is increasing, you know that it is going to be traveling faster here than it is here because the gradient is increasing. That means this object is accelerating. Now, if we're asked to work out the speed of the object at a point, for instance, point A, we can do that using a method called tangents. So what you do is you draw a straight line called a tangent to the curve at that point. So it should just touch at that point. And apart from that, it should be about even. So about the same distance away there as it is there, or as close as you can get it. Once you've drawn your tangent to the curve, you can put in two more construction lines to form a right angled triangle underneath your tangent. And it's these lines that we're going to use to work out the slope or gradient of the tangent. So if you read from the graph, on the vertical axis, you can see that the distance goes from 140 down to 30, which is 110 meters. And on the horizontal axis, you can see that the time goes from 110 to 40, which is 70 seconds. Now, once you have these two bits of information, it's relatively simple. You just use your familiar formula, speed equals distance divided by time, substitute in your values, gives you an answer of 1.57 meters per second, which is a good approximation of the speed of the object at that point A.
So to summarize what we know for distance time graphs, the gradient or the slope tells you the speed. A straight uphill section means it's traveling at a steady speed. The steeper the slope is, the faster the object is traveling. A flat section is when the object is not moving, it is stationary. Curves show you acceleration or deceleration. If the curve is getting steeper, the object is accelerating, and if the curve is getting flatter or less steep, then it is decelerating. Now you do need to learn these. Copy this diagram into your books and make sure you can recognize the various parts of a journey.
Your final task is to answer the two questions based on distance time graphs on the attached PDF and send your answers to Mr. Rahman via Show My Homework by Monday, the 8th of June.